take a look. Troodon is back. So this is a massive like a Voron 2.4. Not really a clone, but this is a couple years old. This originally came with like a rep wrap firmware, and a rep wrap like a duet kind of clone board. But actually I converted this a couple years ago to Klipper. And there's Raspberry Pi 4 with 8 gig of RAM, and then a screen right there. So I finally actually bought it back. Well, I did the conversion for a customer, and then eventually they had two of their printers, he had two of the printers, so I just bought this back. So yeah, actually I wanted a bigger printer, but this thing is huge. I mean, I don't even know if you guys understand the scale of this thing. It's 400 by 400 by 500. So I'm going to pan up, and that's my little Keedy X Smart 3. Now take a look at that thing. This is huge. So I know a lot of people have recently subscribed to my channel because of the CB stuff, but I mean, I have a machine shop in here, and different lathes and stuff, and a bunch of tools over there, but I gotta clean it up in here. So what a lot of you guys probably don't know is I work in IT for a living, and I fix 3D printers. I don't really fix so much of the 3D printers for the home personal stuff, but more like business stuff. But I can't even film it because I have non-disclosure agreements, so I can't even show you what I'm doing at my work. The IT, the data center stuff. So here's some of the other printers I designed. This is a Solaritas, like a crazy fast 3D printer with 4 motors, 4 driver. I gotta get back on this. I gotta machine a new hot end. That's what I got on that thing. And this is my Arsenis quad bed leveling printer. But so now I gotta figure out where am I gonna put this gigantic printer. Here's another side view of how big this thing is. So this is actually, like I said, a Voron 2.4 clone. So it has like the quad. It's not bed. It's quad gantry. It's not from the Voron printers. Voron. Right? I can't even pronounce that. Is our quad gantry level. So there's 4 individual Z motors that go up and down and adjust the gantry. And actually it's pretty accurate, so I'm kind of surprised, with the belts and everything, like that. But, yeah, I don't even know if they ever made the one that was 400 by 400. But it has a nice thick bed on it. Because I did the conversion originally. I put an octopus board in there. This is probably a couple years ago, 3 or 4 years ago. And there's an octopus board in there and a bunch of 2209 drivers. And I designed all this stuff a while back, the front mount for that stuff. But I gotta go through it, and last night I fired it up for the first time in a while. And one thing I noticed is that the end stop here is all jacked up, so I gotta figure out get the end stop working. It won't home because this end stop's all messed up. So I'm gonna fix that. And then I think it's missing the bar here. The little, you can look at the other one, but yeah, there should be like a little thing there. Some actually have these, some don't, but I'm going to take that off, fix that. And it doesn't, I think this originally came with a V6 hot end, but I think the guy put a thing in there. And also notice the fans turn sideways, so I'm going to go through it and fix some of the stuff just to get it running. And then I have let me show you some motors I got. So a while back, LDO sent me these motors right here. They're Super Power HTs. So they're super high performance motors. So I might put these on the X and Y. And then also I have this tool board too. But maybe I'll use this, maybe I won't. I'm not sure. But yeah, it's difficult because the wires go such a long route. They go all the way from this cable chain down to here and around. Even like when I converted it, there's an accelerometer. You can't see it here, but I put like an accelerometer. Not the USB ones, but the original ones we used to use from Klipper. So I got to make sure that works. The firmware probably hasn't been updated in 2 years. So I got to look at that. All right, I'm going to figure out the end stop here. Yeah, this was definitely not a cheap printer. I mean, it was very well built. I mean, for the time too. I mean, this thing had an orbiter motor on there. I mean, this was definitely pretty dialed in. Alright, so might or might not keep the orbiter. I'm not sure. I kind of like those LGX Lite, like the same thing I have in the Orsina's printer. So I might redesign the whole extruder head here. And I don't know if I'm going to go like CAN bus or just toolboard or the individual wires. I mean, sometimes it's easier to troubleshoot with the individual wires than sometimes a CAN bus or a USB can be a nightmare to troubleshoot. So, like when you have the individual wire run, you can see what actually failed, if it's the end stop or if it's the thermistor. You know, it's easier to test, so you can test the wire too. Because I've actually had, with some of my big Tree Tech boards, you know, just intermittent issues with the CAN bus or USB. So, yeah, CAN bus is a communication. You have to have it wrapped and shielded. It's a lot of things you got to do with it. There can be actually electrical interference. You know, a couple of years ago, maybe a year or 2 years ago, I was fixing a lot of personal home 3D printers, and I kind of got into that during COVID because my IT stuff, businesses were all shut down, and my IT stuff, I wasn't busy with my IT stuff, so I had a lot of more free time, and I had to do something. So, but now that like IT's back and businesses are open again, it's like I don't have a lot of time to fix the personal ones. You know what I mean? I can't talk on the phone to some guy for 30 minutes when the whole printer costs $150. So, you know, that's why I just kind of focus on, I'm trying to just focus on the business stuff. I don't have time for the personal stuff so much. But it was fun. I fixed hundreds of 3D printers. Like I said, it's just, man, busy. I mean, there is no perfect printer. I mean, I've worked on so many printers. Every single printer has issues or design flaws or annoyances. So, yeah, this one's only held on by one screw. So the goal of this part 1 video is just to get this thing printed again. And then maybe I'll do the individual upgrades separately, you know. You know, like the Super Power HC, the better stepper motors. Like I said, I got a lot of work to do. I got to upgrade firmware, all kinds of stuff. Alright, so take a look at this hot end. So originally this thing came with a V6 hot end. And then, so I don't know if that's a Fadus, I don't know, or Fadus clone. But it actually has like that newer round, like ceramic heater. I don't know what they call it. It's not round. It's not like your typical like E3D heater block, the square one, the rectangle one. Get this out of the way. So it has a newer style little tiny heater block. So it's interesting how they use the original like V6 style heatsink here. So I'm gonna put that back in there. You know, now let's see. It started to bring back memories when I worked on this print. There was a lot of little design flaws that it's almost like they rushed into production and didn't fully look at it. Because look at this. So this is the actual end stop, Z or the X end stop, right? But interferes, the cable chain interferes with this. And there's a full enclosure on this thing, but see that right there? So my options are either shorten this, which is part of the orbiter, or I gotta design a new bracket here, which goes out a few more millimeters, maybe 5 millimeters more out. Because yeah, like I said, it's, and this is the factory location for the end stop. So yeah, I remember this being an issue before. So I'm gonna have to design a new bracket here, and actually maybe make it a little more stable too. Interesting how they have a lift up here, you know, so it'd go up and down here. All right, so I got to redesign that because I don't want to just run it like that, you know. It'll only take me a couple minutes to redesign it. All right, so my new end step gives me enough room where it clears the actual orbit. I don't know why they designed it like that. I have no idea. All right, so that gives me a couple of millimeters. I can get all the way back to. Alright, so when I turned it on, I have this, yeah, I remember it has this fan that's running 24/7, so I might fix that with the pulse width modulated fan that turns on and off with stuff there. That didn't go, that's weird. Yeah, it has a really old version of Klipper screen on there, so all this stuff has to be updated. Alright, let's try to home it. Okay, home all. I should home X. Okay, end stop finally works again. Home Y. I mean, the gantry needs to be level 2, but I have to first home it before I can redo the yeah, I can see that the gantry is way off. So, you know what's funny is I actually had this configured. I had this whole thing working in Marlin too. So originally we had gone from RepRap, and then I created a configuration for Marlin, and then we moved over to Klipper. JST connector on the back. Alright, BL Touch works. Okay, So the gantry is way off. So let me do a quad gantry level, which is G32. Alright, looks like we're good. I got my Orca Slicer configured. Looks like this is a really old version of Klipper. So I'm going to have to update this Klipper, recompile the firmware, flash the board. It's a Big Tree Tech Octopus. Alright, let's see here. Temperature. Update Klipper screen. I know we were having issues with the PID tuning. Like, we had a lot of issues with overshoot. Alright. Fan came on, looks good. So I'm going to go back and see if I might have to do a PID tuning, but the issue is it was going up and down. I think you gotta remember, look how long the wire is. That's to go up all the way around here. It's such a big printer, right? I mean, that's a lot of resistance on a very long wire. Up and down through to the board. Board is over here. So, as you can see, it's already up at 225. Yeah, that's the issue, is like it was having a lot of issues like with overshoot. So let me do I'm gonna do a PID tune. And then it goes down too far. So the MOSFET the MOSFET on the main board turns on and off, on and off, on and off. So once it gets to the desired temperature, you know, the MOSFET's on it's on the whole time, and then once it gets to the desired temperature, it fluctuates. So it needs to know how long to turn on and turn off. You know, that's what it needs to dial in when you're doing PID tuning. Alright, so there's definitely an issue going on here. Like, I can pull the motor turn in the back, but the orbiter's not moving, so. Alright. I remember this thing being pretty fast. It just kind of started extruding for a second, so it could be like a loose gear. Let me see. Alright, it's laying down plastic now, but I think I'm going to check the motor current on the stepper motor, the extruder motor, the little Lima 14 pancake. Not pancake, it's like a little Lima 14 round. Because normally I was only about 0.1 millimeter out. It should have had enough to push through it, but okay, so let's hang go, see what happens. Yeah, I do remember this printer being fast. So I'm gonna have to reset up the my accelerometer, get all the G code dialed in. Yeah, the accelerometer is like one of the older style, like non-USB versions. So it actually connects directly to the Raspberry Pi. You know, so one of the nice things about the Troodon though is that everything's made out of metal. Like all the parts, everything's actually metal. So like the whole gantry is metal. There's no 3D printed parts there. So printing right now, it looks like it's. I memean, this is really old. I'm just using my really old filament, so it could be a lot of water in it. I mean, I live at the beach, but I feel like it's kind of under extruding. So I can look at this. Either the gear is slipping. I mean, hopefully there's a 0.4 nozzle or 0.4 nozzle. But I got to make sure the actual degree of the steps. Yeah, I think I'm going to change the light strips too to better lighting. Maybe add more lighting to it. But yeah, you can tell this is under extruding. So what I was saying is maybe the degree is not set right. Yeah, you can just see that it's not good light, but it's. I mean, this is under extruding. All right, so I'm gonna go back and I'm gonna look at the motor. This is actually a moon stepper, so I'm gonna look at the specs of this motor and make sure if it's 1.8 or 0.9 degree. All right, I'm gonna try this again. So it actually is a 1.8 degree stepper. I looked at the specs. It is like a name brand stepper, so I mean, there's good information on it. I ran my needle, see if the nozzle's clogged or something like that, but yeah, it definitely seems like it's under extruding. So, well, it's still under extruding, and I'm thinking like the stock configuration, like I'm setting this thing 500 milliamps, so this thing should definitely be warm, the stepper motor, but it's not even warm. So when you do the sense current or on the actual driver, sometimes it can create problems. So I'm gonna look at that, because actually at 500 milliamps, this thing should definitely be getting warm. Yeah, there we go. Take a look. Definitely needs some tuning, but pressure advanced tuning. But yeah, that's weird that it was. I'm not used to seeing that sense resistor on the 2209 driver for the extruder set. Even though they say that for the orbiter configuration, but it didn't seem right to me. And I've worked on many printers, so. All right, get the firmware updated. So it's like February 22nd, 2025. It's like 4:39. It's updated. Klipper screen's updated. I'm gonna do another. Yeah, heats up really fast. The cool thing about this bed is it's 110 volt AC running on a solid state relay. But look how thick that piece of aluminum is. It's crazy. It's a really nice printer. Like I designed like the MOSFET channels. Yeah, I mean, I did a lot of work on that. I mean, I spent probably 20-30 hours getting this thing converted and dialed in, you know. Just Klipper, but then like I said, I did it in Marlin too. Alright, so as I had getting down to get the SD card. I'm still going to update some of the macros, because I actually run, yeah, that's different now, it's cool. But, I need to update some of the configuration, the macro start end scripts and stuff, G-code scripts, start and stop. Alright, first phase is done. So last night I got the accelerometer working last night. Ran an input shaper test, dialed it in, just got the pressure advance tuned in. So let me show you what it looks like. I mean, it's actually kind of amazing for how big that printer is and how good this thing prints. So this is no input shaper. As you can see, the corners project it, and the light here, and that's 0.04. So I'd say it's definitely between 0.04 and 0.05. So the thing is, when you do too much input shaping, it becomes sort of puffy. The flat lines becomes puffy. It does the opposite. So I'm guessing either 04 or 05. Yeah, I don't know. I'll experiment with that. It's very close though. But alright, so that's that was phase number 1. Alright, so I've already designed a 5 kilogram spool holder, which with what's it called, a filament sensor, and I might upgrade to 2240 drivers. And like I said, I mean, the next video, maybe I'll do some speedies to put those superpower HTs in there, or some speedy powers or something. But it's actually printing so good right now. It's like, do I change it? I don't know, man. That's actually pretty incredible for a printer that big. Usually it's hard to dial in big printers because you have more mass. You don't want to have more mass, but it's harder to keep things in straight or plane or whatever, because you're going further across the thing, so it's harder to keep them straight when they're much bigger printers like that. So this is actually incredible for how big that printer is. All right.